Hello to all my wonderful calculus students. I want to go over this activity with you because I didn't like the way it went today in class. I think I could have done things a lot differently. So I feel it necessary to go through this solution with you to make sure you understand it, to give you that foundation that you need in order to get through the rest of this learning target. So without any further ado, let's talk about this preview activity. And so we'll start with part A. So they give us this function, and they said determine all the critical numbers. Now to determine the critical numbers, you're going to have to find f prime of x, and then figure out where f prime of x is equal to 0, or figure out where f prime of x is undefined. All right, so the first thing I want to do is I'm going to simplify f of x slightly. So what I'm going to do is I'm going to take the denominator and I'm going to expand the x plus 1 squared. So this is x squared plus 2x plus 1. And so that gives me 2 plus 3 over x squared plus 2x plus 2. And so now I'm going to take the derivative of that, f prime of x. Well, the derivative of 2 is just 0. And so now I'm left with 3 over x squared plus 2x plus 2. And so to find the derivative, I'm going to say low d high minus high d low over the square of what's below. That's the quotient rule. Now, low times the derivative of the high. If you think about the derivative of the high is just 0. So low d high is just going to be 0. But then I have minus high d low. So that's going to be negative 3 times the derivative of the low, which is going to be 2x plus 2, over the square of what's below. And the square of what's below is going to be x squared plus 2x plus 2 squared. Okay, so to find the critical numbers, the first thing I do is I set this equal to 0. Well, if I set negative 3, this is from your pre-calc days, if I have a rational function, which I do here, and I set that rational function equal to 0, 2x plus 2, over this denominator, x squared plus 2x plus 2 squared. If I set that whole thing equal to 0, and I multiply both sides of the equation by my denominator, right? That's to solve this thing for x. That means I'm going to be multiplying 0 times that argument, which is just 0. So in other words, what I really have here is negative 3 times 2x plus 2 is equal to 0. And if I use the 0 product property, negative 3 does not equal 0, so I don't care about that. And I get 2x plus 2 equals 0, so x must equal negative 1. So there's going to be one of my critical numbers. To find the second critical number, I got to figure out where this function is undefined. So I'm going to take this denominator, and I'm going to set that equal to 0, because wherever that's equal to 0 is going to be where the function is undefined. Now, to do that, I think what I'm going to use is I'm going to use my calculator. Well, let me show you why. Because if I take my denominator, and I'm going to write over here now, so if I have x squared plus 2x plus 2 quantity squared equals 0, I can take the square root of both sides. That's going to get rid of the square. And I'm left with x squared plus 2x plus 2 equals 0. And I know for a fact that that doesn't factor. So I could either use the quadratic formula to figure out my value of x, or I can simply just open up my calculator and graph this thing. Okay, so I'm going to put x squared plus 2x plus 2 into my calculator, do a zoom 6, and I can see that this parabola doesn't hit the x-axis anywhere, which means there is no place where the denominator is going to equal 0, which means there are no restrictions. So that tells me that my critical numbers are simply x equals negative 1. So that's going to be my answer for part A. Let's move on to part B. Part B, they ask me to set up a first derivative sign chart and then determine all the intervals for where f is increasing or decreasing. So I plot my critical number and negative 1, and now I'm going to do my sign chart. So I'm going to test a value that's to the left of negative 1. Think about this logically for a second. Look at the denominator of f prime. The denominator is squared. So it doesn't matter what value I put in for x. I know that my denominator, whether it's less than -1 or greater than -1, the denominator will always be positive. When I put -2, if you think about substituting -2 in for x, that's going to give me 2 times -2, which is -4. -4 plus 2 is a negative number. Multiply that by a negative number, and I end up getting a positive. All right, so I get a positive divided by a positive, so I know that f prime is positive. Now, when I put in a number to the right of -1, let's just put in 0. Again, I know the denominator is going to be positive, but the numerator, if I put 0 in, 2 times 0 is 0, plus 2 multiplied by -3, that gives me a negative. And a negative divided by a positive is a negative. So f prime is going to be less than 0. So if you think about your chart for a second, know is that when f prime is positive, the function is increasing. And when f prime is negative, the function is decreasing. So I can say that this function, f of x, is increasing over the interval -infinity to -1, and f of x is decreasing over the interval -1 to positive infinity. So there's my answer for part B. So in part C, they ask me, does f have a global maximum? Well, there's only one maximum on this graph. The maximum happens at -1. And I know that because the derivative goes from positive to negative. So when the derivative goes from positive to negative, or you can think of the original function going from it's an increasing function and it changes to a decreasing function, then we know it's going to hit a max. That's the only critical number. So therefore, -1, x equals -1 must be a global max. Now, I'm not going to write out all my reasoning because I just said it verbally. But then the question does say, and we didn't talk about this in class, the question says, what is its value? And where is the maximum attained? So we said x equals -1 is a maximum, but what's the value? So in order to find the value, I have to evaluate f of -1. And when I evaluate f of -1, and I'll let you go through all the work of doing that, but you end up getting f of -1 to equal 5. So that answers part C. Let's move on to part D. We're asked to take the limit as x approaches infinity of f of x. We're trying to figure out how f of x behaves here. What do we know? We know that there's one global maximum at x equals -1. We know the function is increasing as it approaches -1. It's decreasing as it leaves -1. But what's happening at the extreme values of x? So what's this function doing when x gets really, really large? Well, when we find the limit as x approaches infinity of f of x, which we've already calculated f of x to be this function right here, we have to kind of just use our logic a little bit here. As x gets really, really big, because what you cannot do is you can't just plug infinity in for x. So you have to think about this logically. As x gets really, really big, the denominator is going to get huge. And if I have 3 over a very large number, that's basically 0. 3 1/millionths, 3 1/billionths, that's a fraction that's basically 0. So as x gets large, I have 2 plus 0, which is just going to be 2. So I can say that the limit as x approaches infinity of f of x is equal to 2. Likewise, when I have negative infinity, the limit as x approaches -infinity of f of x. Well, let's just go back and look at our f of x function again, but now I'm putting in negative infinity. Well, negative infinity squared, okay, that's going to be a huge number. Plus 2 over x is going to be a huge number. Plus 2 is going to be a huge number. So again, I have 3 1/billionths, 3 1/millionths. And even if it's negative, 3 over -1 billion, 3 over who cares? because it's still going to be 0. So I can say that the limit as x approaches negative infinity of f of x is also going to be 2. What this means is, if you think about the function logically, okay, try to imagine what's happening here. There's a horizontal asymptote at x equals 2. As x gets really, really large, this function just starts hovering around 2. Okay, so that brings us to part E. Kind of a weird question. It's kind of a tricky question, but you have to think about it again from a logical standpoint. It says explain why f of x is greater than 2 for every value of x. So what we're asking here is, we know there's a horizontal asymptote at 2, but where is this graph hovering? Is it hovering above x equals 2, or is it hovering below x equals 2? Well, the reality is that this 3 over x squared plus 2x plus 2, even though we're getting larger and larger and larger, it's still going to be positive. All right, whether it's positive infinity or negative infinity, and again, test some very large numbers here, you're going to see that this fraction is going to be positive. Therefore, it's going to be slightly above 2. So that's my explanation as to why the function will always be greater than 2 for any value of x. And that brings us to the final part, part F. This is a really smart question. It says, does F have a global minimum? I feel like they're kind of baiting us here. Like, we think it should have a global minimum, or how do we know that it doesn't? But the reality is, the only way a global minimum could happen is at a critical number. The only critical number we got was x equals -1, and we found out that that was a maximum, an absolute or a global max. So there can't be a global min. If there were a global min, there would have been another critical number. So I think another good thing to do here would be just to sketch a graph of this thing. Now, you can either put this into your graphing calculator and look at it now that we've kind of broken this thing apart, or we can just kind of figure it out based on what we found. We know that at -1 there's a maximum. We know there's this horizontal asymptote. So this is my dotted line. There's my horizontal asymptote at 2. And we know the graph just hovers above that horizontal asymptote at all times. So what happens? This graph is increasing until it gets here, and then it starts decreasing, and it just keeps getting lower and lower, or closer to 2. So this should be the way the graph looks. Now, I haven't put this into my calculator, but you could try it, and hopefully I'm right. But that's how you do this activity. It's a loaded activity, and it's each question is very, very difficult, which is why I wanted to walk it through with you so that it made more sense. Let me know if you have any questions.